All right, joining me now is Dr. Franklin Gaudi. Franklin works as the Executive Vice President of Design for Laurel Ag and Water in California, with a focus on redefining the industry standard for irrigation design. I love it. Prior to his current role, Franklin was an assistant professor and project manager for the Irrigation Training and Research Center at California Polytechnic State University and San Luis Obispo. Love that town too. Welcome, Franklin. Thank you for being on the podcast today and appreciate you taking your time.
Yeah, thanks for having me.
You got it. And so here's the backstory on you and I, Franklin. I heard your presentation on irrigation distribution uniformity at an industry event in late 2022 in California. And I was blown away by your knowledge and your passion for this topic. And I can just recall writing down notes so fast I could hardly keep up with the content. And that's one of the real reasons I wanted to get you here today on the show, so we can spend a little more time and really dig down in the underground on this topic of distribution uniformity. And I can say, if you don't have irrigation in your vineyard, you still are going to be interested in listening to what we talk about today. So, Franklin, can you tell the listener here a little bit more about yourself and your background and how you became so interested in design and the science of irrigation?
Yeah, absolutely. So I grew up on a family farm down in the Imperial Valley, and down there they only flooded for the most part. And a farmer friend of mine that was working for when I was in high school said, "Hey, Franklin, you know the future of California is in water." And I kind of took that to heart, and so I found Cal Poly State University and a program there through the Irrigation Training and Research Center with Dr. Charles Burke, and I applied, and he put me to work basically. And so for 23 years, I spent working with him in the center and just kind of absorbing everything that I could. And part of that time too, I spent 14 years teaching at Cal Poly irrigation classes of all kinds. And then about 2 years ago, I decided to move on to the private sector and start working with Laurel Ag and Water as a design engineer, I guess, for them. So I have a design team, and we now kind of put all the things that I always, talked about in theory into practice. And so now I can't just put on there, like, oh, see me bad, now it has to be right. Cause it's going out to the real and stuff. So that's been kind of a nice change of pace, and it's been fun to actually watch these projects go into the real world.
So let's start at real high level, real basic, and say, what is irrigation distribution uniformity? Why is it so important? Why does it matter? And why do growers need to be on top of this and testing it? And we'll go more into how you test it later.
Sure. Yeah. So I would start by defining it. Let's start there, right? Distribution uniformity is a measure of how evenly water gets applied to the field. Okay. So ultimately we want every single spot in the field. In fact, when we talk about grapevines in particular, we really want every vine to get the same amount of water. We don't really care that the area between the vines doesn't get the same amount of water, because we're not really growing anything there unless we have a cover crop or something, right? But then there's a different strategy to that. But if we're just focused on growing grapevines, right, we want every single grapevine to get the same amount of water, whether it's at the top of the hill, the bottom of the hill, anywhere in between. So we have methods for determining then what the uniformity would be across all these vines in the field. So that's the first thing. The second thing that I maybe would add to this is that this is different from irrigation efficiency, which a lot of people talk about. Irrigation efficiency is the measure of how much water is beneficially used, meaning taken up by the plant for production of wine, right, in this case, compared to the total water applied. And so when you compare basically the input going into the plant compared to the water that actually is used for evapotranspiration, you have a difference there, and that's efficiency.
Mm-hmm. Okay.
So uniformity, so with that said, we can be actually very uniform and be inefficient. And we would do that by, say, applying twice as much water as you would need, right, to the plant.
There are some growers who apply insecticides, for example, not just fertilizers, or even fungicides via drip irrigation. And so if you've got like Pierce's disease and you're trying to combat that with an insecticide through the drip, well, just think about it this way. Some vines are getting a low dose of insecticide that can promote resistance to development by the pest. And then you can end up with a source of inoculum right in your vineyard because those vines didn't get a treatment. And now you have the disease with an epicenter in the vineyard. And that could all go back to something like distribution uniformity. So this is in my opinion, a bigger thing. My point is a bigger subject than most growers realize. And so that's why I wanted to bring attention to it.
Yeah. To
So
add to that as well, uh, let's say you're using soil moisture sensors. Where do you put the soil moisture sensors? If you have really even uniformity, then in your uniform soils for the most part, right? It doesn't really matter where you put the sensor because it may be representative of what's going on in the field. But if you have wet spots and dry spots, you may not be putting the sensors in a spot that is actually representative of a majority of the field. And same with pressure bombs. If you're doing or pressure chambers, if you do leaf bombs analysis, right? Knowing that all your plants are uniform as possible, you're going to get better sampling than you would if you had non-uniformity in the field.
that's another great example. And that goes right to the vineyard manager and how they're collecting data. So I love it.
Correct.
Sometimes, I've gone by I use soil moisture sensors in the vineyards I work with, and I'll go by it and the drip emitter's clogged right next to the sensor. So that's another problem altogether. We're gonna skirt by that today. But please, folks, if you have a soil moisture sensor, please make sure that the irrigation is running where that sensor is, period, whether it's a high or low DU. What are the best and easiest ways then for growers to test their distribution uniformity? Sometimes we say DU. And how often should they check it? So, what does a typical distribution uniformity test scenario look like in a vineyard? Are we going out there with test tubes and putting them under every emitter? What's that going to look like?
Yeah, it's great. Great question. So the Irrigation Training and Research Center at Cal Poly developed a procedure for doing evaluations of all irrigation systems. We'll focus on drip, obviously, and vineyards in this particular case. So to be clear, before I get into kind of the testing procedure, there are really 4 components of non-uniformity that we analyze when we're doing an evaluation. Okay. The first one is pressures. Ultimately, we would want every single drip emitter in the field to be at the same pressure. We know that that's impossible because of elevation change and friction in the tube and stuff like that. But ultimately, that's the goal. Minimize pressure variation in the field. The next one is non-uniformity due to spacing. In some vines, for example, you might have a 6x9 spacing in some area of the field, but then you switch to a 7x9 spacing in another area of the field. If you continue to keep 2 emitters per vine and 1 gallon per hour per emitter, for example, you now have 2 gallons per hour going over a 6x9 spacing in one area of the field, but 2 gallons per hour going into a 7x9 area in another spot in the field. And so therefore the water that you're applying is going to be less on the 7x9 compared to the 6x9. Now, of course, most growers typically don't have multiple spacings, but I've come across it several times because they added on and they realized that they wanted to have a different canopy arrangement or whatever it was. And so
closer space vines, whatever it might be in the next planting. Sure.
Yeah. So that's 2 of them. And then the third one is unequal drainage. And so what happens here in this particular case is if you're growing on the side of a hill, right, and you turn off the system, that the emitters at the bottom of the hill will continue to run because the water is draining out of that tube and coming out of those emitters at the bottom. So the grapes at the top of the hill may not get the same amount of water as the grapes at the bottom of the hill because the tube drains to the bottom of the hill naturally, right?
Yeah. And I'll add to that. A lot of times, sometimes soil over time erodes and moves to the bottom of the hill. So you sometimes have higher soil vigor at the bottom of the hill. So now if gravity's watering those vines more, you're just putting fuel on the fire, so to speak. Sounds
Yeah,
like.
sure. And of course, manufacturers of drip emitters and stuff now have technology to help prevent some of that stuff. They're called C&L emitters, close no leak emitters. So when they get to some minimum pressure, they actually will close off and prevent the drainage. So
That is cool.
Yeah, there are plenty of opportunities out there to fix that problem.